Yeah. So 25 years ago, on the 28th of April in 1995, the Cave Creek viewing platform collapsed and killed 14 people. You might wonder, why have we selected this failure for the second webinar of this series? We selected because most of the lessons to be learned are applicable to all types of engineering, and also because you only needed a basic understanding of structures to understand the technical parts. And because of the time frame, many engineers, while they may be aware of Cave Creek, will be unaware of the details and the reasons behind the collapse and the potential lessons to be learned. So in today's lesson, we will look at the lessons to be learned. The agenda, we'll look at what happened, why did the platform fail, general causes of the failure, some lessons to be learned. We'll ask the question, what might you stop and start doing in your practice as a result of these learnings? And there'll be a period for discussions afterwards. So 17 Polytech students and a DOC Conservation Field Centre manager crowded onto a platform high above Cave Creek. Now, Cave Creek is located 5 kilometres to the northeast of Punakaiki and is surrounded by the Paparoa National Park on the west coast of South Island of New Zealand. The platform collapsed and fell about 30 metres, and 14 young people lost their lives and 4 others suffered serious injuries. Perhaps it's of value to look at an eyewitness account from the survivor, Carolyn Smith, and she says, "We continued walking, and as the track became narrower, we walked in pairs. I was approximately in the middle of the group as it reached the platform. I stepped into a gap on the left-hand side of the platform to have a look. I looked over and then went to take a step back because I didn't like heights. Suddenly, without any warning apart from yells of surprise, the platform was falling under our feet. It began sliding down at approximately 30 degrees and then tipped and fell vertically, with everybody falling in front of it." After the platform collapse, a commission of inquiry was established under Judge Noble. They actually responded very quickly, or certainly quickly in today's terms, 6 months later in November 1995. So the platform itself, just a bit of a description. It had 3 rows of wooden fence posts as piles driven into the ground, and they varied in size between 110 and 140 millimetres in diameter, and they were protruding above the ground between 200 and 400 millimetres and had an acceptable tolerance in height between each other. The rear row had 4 piles, as did the centre row, but the front row only had 3. The rows of the piles weren't parallel. And on the front, or on the side of the piles, was nailed a timber 150 by 50 with a couple of 100 by 4mm galvanised flathead nails. Because the 3 rows of the piles were slightly misaligned, there were some timber packers used to fill the spaces. At right angles to the bearers, there were 7 200 by 50 timber joists attached to them by the use of 200mm skew nails and with timber trimmers at each end of the joist. On top of the joists were 150 by 25 timber decking, and also around the perimeter of the platform, 100 by 50 timber handrails. So the platform, when constructed, measured about 3 metres by 3 metres and overhung the front row of piles by about 1.4 metres. You'll see the sketch there of the plan of the structure, including a cross-section. You can see that the cantilever out over the edge of the ravine would be a little less than the 1.4 metres from the front row of piles. At the rear of the platform, and abutting it, there was a concrete steps which were built a little bit after the original, of an indeterminate depth and weight. And they'd been surfaced with timber. They'd only been attached to the timber by some 75mm nails and some dovetails set as part of the boxing for the steps. The timber itself was Pinus radiata, generally number 1 framing grade. Not known to what extent the treatment, but hazard class H3 had been ordered. This would have been satisfactory for the deck, unsatisfactory for the timber. That was in contact with the ground, particularly the rear and the middle bearers, where moulding of the soils would have led to premature decay. And so the purpose of the whole deck was to view the Cave Creek, which emerged from a limestone some 30 metres below, known as Cave Creek. No structural or geotechnical engineering input. The deck was designed by a dock staff member who was trained as a motor mechanic, and you've got the layout plans there. They did not obtain a building consent prior to construction, although they did attempt a retrospective application later on, which didn't proceed through. So the deck was actually built by dock staff and prefabricated, then disassembled and lifted to the site by helicopter, and then assembled on site by dock staff and volunteers. There were a packet or a package of bolts supplied, but were not included. So the inquiry in their deliberations found that the standard of workmanship was adequate for the deck fastening, but was substandard in the following areas. The piles weren't properly set out and aligned. Tackers were used for the bearer spacing, the misaligned piles. You can see this on the slide. One nail only dented a pile on bearer joist 2 and didn't significantly penetrate the pile. Some joist to bearer connections had one nail, another had nails that missed altogether. Apparently there was no plan used, or the plan was not followed. Normal construction practice with regard to the bearer pile connections was not followed. There was only 3 piles in the first line, and the evidence was that one of the piles didn't find solid ground. So the sequence then, they cut off the piles, placed the bearers, fixed them with the 100mm nails as described before. The joists were nailed to the bearers, skew nails, and then the decking followed. There was some suggestion that there was a steel bar to be included to tie the steps to the deck, but that bar was apparently not delivered on site, and there was no detail of how that was to be fixed. So there is a model of the platform that was constructed for the commission. So the actual mode of failure, and we had hoped to have a little video on this, but we were unable to download it. But it is available on the website, which sort of shows a test loading of a replica of the platform loaded with water drums and filled. And you can see quite clearly the sequence of events, which was firstly the failure of the nailed connections. The front of the platform started to sink. The platform rotated, failed, and then fell vertically to the occupants 30 metres to the rocks below. A commission of inquiry was held, as I mentioned earlier, and their first finding was that the dominant fault was that the platform wasn't constructed in accordance with sound building practice, resulting in the catastrophic failure. The secondary causes, the Judge Noble identified 6 causes, But he sort of set a bit of a background as to how the environment in which this happened. DOC, Department of Conservation, was established in 1987 and then restructured very shortly after in 1988. The department had assumed many of the powers and functions previously carried out by New Zealand Forest Service and the Wildlife Service of the Department of Internal Affairs. And the judge formed the firm impression that things were lost in the transfers from the old structure to the new. An example being that New Zealand Forest Service had a carefully structured system using skilled employees for designing and building quality structures. And I understand that they also used the Ministry of Works to provide technical guidance. These systems weren't transferred to DOC. In DOC, there were field centre managers who became responsible for such structures, but without any systemic guidance on how to ensure that the structures erected met standards for design and construction. The West Coast Conservancy is the largest of all of the 14, with about 1.8 million hectares, 4 national parks, and 88 scenic reserves. And the judge found that the staff were dedicated, enthusiastic, and hard-working, but some had difficulty in adapting to a regime of setting priorities, and that their work was hard to define in detail, and thus therefore hard to schedule, and also often disrupted by responding to emergencies, for example, arising out of bad weather. So the judge quoted that the secondary causes of the collapses had to be considered against the multiple backgrounds of the services provided by and the structure of the department itself, the resources of the West Coast Conservancy, its region, statutory obligations, and the pressures on them and the adequacy of the resources and the task increasing demand on those resources. That under-resourcing had been under constant refrain from both the Chief Executive, New Zealand Conservation Authority, and conservation boards and other organisations. The visitors' numbers were increasing and rising quite rapidly. While the staff were very committed to the department, particularly for those that had a keen conservation bent and were very enthusiastic people. But the lack of resources gave rise to a culture of doing more with less. And I'll come back to that later on because I think that's a very significant part. Also, compounding this was frequent reprioritisation, cancellation or postponement of things. There was also an element in the external to the department, an anti-department attitude by certain sections in the community. Funding of the department was reducing in real terms, and the staff numbers, for those that should know, were inadequate to effectively and safely carry out the department's statutory functions and duties. So when we consider these next 6 causes, that's the sort of background and the framework which they belong. So the first of the secondary causes, failure to provide qualified engineering input into the design and approval of a project. The framework, as I've mentioned a few minutes ago, for the management of design and construction was never laid down and given to conservancies and the field centres, and the officers were inadequately instructed regarding the management and design of such structures. This led to the failure to provide engineering input into the design and approval. There was a failure to adequately manage the construction. Adequate working drawings and specifications would have been provided and should have been under the control of a registered engineer. For the younger people, prior to this Chartered Professional Engineers Act, the only legal qualifications was engineering, was the registered engineer. The plans should have been followed strictly. No plans were followed. Construction should have been carried out or supervised by a skilled tradesman under an appropriately qualified person, and that didn't happen. And the project should have been appropriately planned, sequenced and managed. It wasn't. So I actually covered a fair bit of that second slide there. So I'll go on to the next slide. A building consent was not obtained, and staff were unaware of the recent changes in the legislation that required a building consent to be obtained. We did try later on to get one, but that was not completed. The Commission found that the lack of a resource consent wouldn't have altered the outcome, but in terms of health and safety, the judge was quite critical that the newly implemented Health and Safety and Employment Act wasn't taken note of, and there wasn't a risk analysis done, and the safety of the personnel and the employees was compromised by failure to identify hazards and take practicable steps to minimise the risk. And that would, of course, have meant using input from appropriately qualified people in the design and construction and checking of the structure. So lack of warning signs. There was a warning sign that was ordered but wasn't put up, limiting the number of people on the platform. Now, IPENS, when was Engineering New Zealand, was formerly produced evidence saying that they didn't support the use of warning signs, and that's a view I concur with. Occasionally there may be special circumstances, but in general we should be designing projects, particularly things like this, for the maximum loads that can be physically put in place. So had there been a warning sign, would it have made any difference? And there was evidence presented to the Commission that even with 5 people on it, it most likely failed. And just a thing on platforms, and I've just had a recent case myself on reviewing a platform in a viewing platform in a park. Need to also look at what people do on these platforms. And I've certainly had evidence on the one I'm looking at that people get up there and just try and make a synchronized effort to get the platform bouncing. And there was some evidence in terms of Cave Creek much later that somebody did appear on TV and said that they were in fact doing that, but that's unsubstantiated. Lack of inspections. Again, it's a question of someone was doing the inspection, what was the guidance? There weren't any, but if there are not proper plans that have been approved and checked, prepared by appropriate people, would that have made any difference? So the judge also found systemic failure, and he concluded the lack of a proper project management system explains why each and every one of the preceding secondary causes occurred. There was no proper and adequate management system, either inherited by or formulated by the department on its inception. There was no system that existed on the West Coast to ensure that a suitable structure was built at Cave Creek, and there was no evidence presented at the Commission that established that a proper department-wide system of project management, 14 conservancies and the 66 field centres existed, and that there was no evidence that the staff had been trained or appropriately skilled or even knew where to get assistance and when to get assistance. Whilst there were some successful projects, the one at Cape Foulwind, which did perform well, most of them didn't. And so the judge concluded that the staff just weren't qualified to recognise and determine the need for qualified input, and so didn't in this case. There was no peer review system, there was lack of promotion of health and safety, there was a poor system for dealing with complaints. Apparently there were a number of complaints, but they were not dealt with or attended. They were talked to about the poor or no inspection regime, and there was poor recording of skills and competence and a lack of adequate resources. So that was dealing with the Commission. So if we start to think how we can look and learn from this, those of you that attended the earlier webinar and perhaps the talk I gave on learning from structural mistakes will by now be familiar with the Swiss cheese model. Imagine a series of slices of Swiss cheese with random holes in it. Some of those layers could be by a latent, not a failure laying dormant, if you like. Some that are active that occurred at the time of the failure. Sometimes you have both present. They depend on, this, in this case, systems, lack of engineering, construction and competency. So had a proper risk analysis been carried out by DOC, in this case, there would have been a clearer understanding of accountabilities. The Swiss cheese model was promoted by James Reason, a professor at University of Manchester, and he's done a lot of work on risk and failures. And he says that some of the factors we need to consider are the suitability of individual operators to the activities they're expected to carry out, how well the situational context is organised and managed, which affects the likelihood of operators committing destructive errors and violations. And the table on the next slide, I've already just partially mentioned active failures. These are direct actions, errors, violations, equipment failure, or conditions in the natural environments which cause a catastrophic event. Latent failures are deficiencies in the organisational environment which create an operational situation in which the probability of active failure occurring is increased. And then we've got defensive failures. So deficiencies in any of these procedures or an organisation which doesn't adequately scan activities to identify and remedy errors and violations before they produce catastrophic consequences. In this case, building consent could have been a check, part of a defensive mechanism. And then we've got the organisational failures, core systemic failures, which allow latent failures to develop and active failures to occur unchecked. So from this, and I don't know how well you can read the slide, but on the left-hand side, we've got active failure pathways, on the right-hand side, latent failure pathways. So I'll just go through this quickly. So the organisation processes as far as it applied to Cave Creek. Unclear policy operations responsibilities, deficient project management, no procedures for checking local managers' performance, funding shortfall, inadequate training provision, delegations inadequately defined, no workload monitoring, emphasis on financial accountability, and contradictions between the Public Finance Act and the State Sector Act. So we've got on the left-hand side, we've got the local working conditions, excessive workloads, workaholic staff, need for emergency response, community threats to staff, poor relationships with local government, understaffed by about 30, increased recreational use of land, and do more with less culture, change regulatory regime and restructuring. On the defensive safeguards, could have been the New Zealand Loading Code, the New Zealand Building Code, the Resource Management Act, Project Management System, DOC supervisory systems, DOC safety systems, health and safety laws, and DOC inspections. So on the left-hand side, from the local working conditions, the active failures, many construction failures, plans not used, no technical survey of the site, untrained personnel used, no inspection of the platform, warning signs not erected, and no building consent sought. The latent failure side on the right-hand side, unqualified local managers, mismanagement of resources, constant reprioritisation, unqualified staff used, local management unaware of legislation, supervisory roles ambiguous, no clear conservancy project management systems, no conservancy checking systems, unqualified engineers, no health and safety training, annual inspection often overlooked. And that culminated in the event of the platform collapse and 14 people died as a result. Now, this is a systems model. Unfortunately, it's probably hard to read, but it's actually prepared by students of Canterbury University on a project. But really, this is the purpose of including this was to say that the cave platform was just a part of a total system. You know, we've got the surrounding environment, general public end users, you've got the wider system, the government, you've got the Department of Conservation system, the Punakaiki Field Centre West Coast system, and the cave project, platform project itself, and the subsystem, of course, all working with the environment. I'm not going to go into that anymore, but to emphasise that all these projects, no matter what project you are involved in, are all part of a wider system. So lessons to be learned. And to its credit, the government and DOC got onto this and changed the law to provide for the prosecution of government departments under the Building Act and Health and Safety and Employment Act. Second lesson was to implement effective project management system to increase communication and ensure correct procedures were followed. Third, to ensure design of structures are carried out and certified by appropriately qualified people. Fourth, to ensure that the construction is supervised by experienced qualified people who understand the construction plans and their specifications. To implement a peer review system. Promote health and safety. Implement protocols and procedures for reporting and following up concerns in a timely manner. Conduct inspections during construction to ensure it meets the requirement of the building code. Establish a training and development system. To record skill. Establish a complaint system. An asset management system. All of those lessons from the Commission were adopted by the government and DOC, and they continue to be relevant for all organisations. They don't have to be just a government organisation. These things can all appear to a greater or less extent in any organisation. So some additional lessons to be learned, I think, in it, perhaps with a bit of time elapsed and looking at it from an engineer's eyes, I think that there are other lessons that we can learn. In thinking about that, I think it might be helpful to look at some of the concepts we outlined in the first webinar, and that include how mistakes occur. What do we mean by failure? Look at how this relates to the Swiss cheese model we've just talked about. Why is it that we should investigate failure? What's this memory fade? What about human factors? Systemic aspects which we've talked about, the culture of an organisation, risk management, and how we learn best from mistakes. Sorry. So one of the lessons for me was competence. The employee, who wasn't an engineer, who prepared the initial plans, didn't recognise the limits to his competence. Many of you will have heard of the Dunning-Kruger effect, which is a cognitive bias in which people with low ability at a task overestimate their ability. It's related to the cognitive bias of illusory superiority and comes from people's inability to recognise their lack of ability. In other words, we actually don't know what we don't know. And this raises important issues for all engineers. How do we know limits our own competence, and how can we meet the requirements under our code of ethics? Now, this topic alone would probably be worthy of a full webinar. So I'm only going to ask the questions and leave you to think about the answers. The other very important lesson, I believe, is resourcing. It was quite clear that DOC had developed a culture of doing more with less and was understaffed and under-resourced. I don't think this just applies to government departments. It can apply in all organisations, from large to small. As an example, what happens when you underquote fees? Do you do the same quality of work, or do you skimp, take shortcuts because of the financial impact? What about unrealistic timeframes? All items get adequate consideration. And what about the quality and the skill level and the experience of the staff? Another lesson is load paths. In this, for structural engineers, is a constant theme. We need clear, reliable load paths. They're vital. We need to look at all the load paths, including those for lateral and environmental loads. Are there alternative load paths available? In other words, are there redundancies? How robust is the structure? In this case, the node connections are critical to enable loads to get to the ground. Now, it would have been far better if the bearers had been checked into the piles as far as gravity loads were concerned, and certainly if the bolts provided had been used. And I understand that the bolts might not have been used because they didn't have, at that stage, an appropriate drilling equipment. So positive connections and robust connections between the concrete steps at the back would also improve the resistance to the platform, even if the failure of the bearers at the piles, the platform would have slumped down to the ground, but if it was adequately tied and of adequate mass, could have prevented the whole platform collapsing. Another important one is the soil structure interaction. In this case, there was no geotech information. And thinking about it, you've got a platform high above a 30-metre deep ravine in soils, limestone type soils. I think that geotechnical input would have been vital, particularly the susceptibility of that soil and the environment to erosion and time-dependent degradation, and obviously also influence of seismic effects. Durability, that's another important one that was alluded to in the Commission about the use of the timbers, but not mentioned were the connections, the quality of the connections. You can design guidance on D2 from Engineering New Zealand on their members' resources section. Another lesson, this is one that applies, and I think is grossly under-recognised, is the lack of regular cleaning, maintenance and inspection. It's important on all structures to have regular cleaning and inspections, and the program needs to be implemented and executed. You can download an example maintenance schedule from Engineering New Zealand resource page. And I note that SESOC are promoting a series, seminar later this month on B2, which addresses this issue. Question of memory fade. The question there is Henry Petrosky in his book Successory Failure. That's the question. Does the memory of failures fade with time? And I think the evidence is very clear that it does. It's certainly highlighted in the bridging sector, where about every 30 years, 35 years, similar mistakes are made and similar failures. I think that's one important reason why we should think about Cave Creek collapse today and what we can learn from it. So learning opportunities. First off, Engineering New Zealand are recording these webinars and going to build up a library. I'm not quite sure if that's established. When I spoke to Martin a week or so ago, that wasn't yet on live, but it will be coming up. So that's going to be a very valuable resource. For structural engineers across Australia, that's confidential reporting on structural safety, Australasia. That's an initiative that was commenced in the UK, expanded to Australasia several years ago, and both SESOC and Engineering New Zealand are actively promoting that, and has now gone to the United States. Now, I've recently been appointed as one of 3 New Zealanders on the Cross Oz panel to review these reports and to help prepare presentations. Now, Cross is free for structural engineers, and for anyone that's interested, just put in Cross Oz and log in. And they're about to upgrade their website next month. Another useful resource is Engineers Without Borders. And again, they have a website and they report on some of their mistakes. We can improve our quality assurance system and try and avoid a tick box approach. It's got to be one that really is simple but relatable too. And I'd like to think in structures you need a good understanding of structural behaviour and deformations when you're doing those sort of QA assessments to make sure that the big things get detected. And I think too that a better understanding of human factors for both individuals and organisations is important. This is something I've got quite interested in since the series of talks I've been involved with, and it's something that I hope to be able to provide more information on in the future. And it kind of relates back to the fact that I've interest in aviation extending back 40 years or so, and human factors, study of human factors there has led to reduced accident rates. We need to understand our own limitations and competence. We need to keep upskilling and learning and promote peer reviews or peer-to-peer reviews of our work. I think we need to own our mistakes and share them. And I think that if we can help create a just culture, a just culture is a culture in which frontline operators or others are not punished for actions, omissions, and decisions taken by them that are in line with their experience and training, where gross negligence, willful violations, and destructive acts are not tolerated. Now, we can establish that just culture in our workforce, our technical groups. This would be a useful step, and I know that Engineering New Zealand are currently exploring resources. So learning from failures. So what will you stop? What will you start doing in your practice as a result of these learnings? What changes could you make? Could you perhaps look at the way you check work? How you keep within the bounds of your competence? And how do you ensure that your design is built and used properly? And also, how can you start to establish a just culture in your workplace? Now, Engineering New Zealand have quite a lot of information on this, and there's going to be a printed presentation that Engineering New Zealand will have with some links to some of those resources. So, conclusions. I think that the lessons learnt from the Cave Creek collapse are valid in today's environment, and we'll be better engineers if we take those lessons on board. We can go to questions.
Thanks, Gordon. Certainly appreciated your time there. There's a couple of questions actually that, so there's some questions that have come up on the screen first of all, but first of all, I'd like to pose a couple to you myself, if that's okay. both of which came from the last couple of slides in your webinar. And it's really coming from your personal experience, and feel free to have a think about this and answer them after the questions on the webinar. So you personally, you're a very experienced engineer. You know, you've seen a lot of things. You've done a lot of work in a variety of ways. How do you make sure that you are staying within the bounds of your competence? And the second question, and I'm sorry, was to do with the next question down on the presentation itself. And I've forgotten it. Is there any way we can bring that presentation up on the screen again? Yeah, that's it. So first of all, how do you check your work? Do you know, so I understand that you've worked as a sole practitioner yourself, and now you own your own company and have other people working there. How do you, what are your quality control processes? And the other thing is, how do you personally make sure that your design's built and used properly? So do you want to answer those, or do you want to come back to them after the questions?
Well, I'll try, Martin. I think there's probably at least 3 questions in there. Firstly, in degrees of the one in regard to competence. Yeah, I guess you just got to ask yourself, have I done this before? You know, and am I current in doing that? And I like to compare it to the actions I would take as a pilot. And one of the things in pilots, you've got to do 3 takeoffs and 3 landings in the preceding, I think, 30 days or 90 days. And I think the same applies to engineering, that if we haven't done that sort of design reasonably recently, we need to stop and think and maybe refamiliarise ourselves with the standards, the codes, and the practice, so that you can be sure you're okay. And if in doubt, consult with somebody else. You know, as a sole practitioner, that's not easy. And of course, that's one of the reasons behind the formation of the Engineering General Practice Group, so that people can bounce ideas off each other. And I've certainly been doing that as a member of both of the Waikato group of engineers, about 12 or 13 engineers that meet monthly, and also the Rodney Engineers Group. So having a sounding board for small practitioners, people you can go to and ask. And the other thing is keep training, keep learning, keep asking questions. And if in doubt, get somebody to take you by the hand and work through the project, particularly if it's something you're a bit rusty on or you've not done before. For example, for me, I do quite a lot of work on cranes, and I got involved in repairing damaged cranes, learning about really high yield strength steel and how to weld it. You go and seek the experts. We went to the welding centre at Hira and got the expert advice. So I think, you know, be a bit cautious, but not super cautious. You've got to really have a good look at yourself. That's how I'd answer the competency one. In terms, now you might have to run the other ones past me. I've forgotten them all now, Martin.
So when you're putting your designs together and before they go out the door, how do you check them? Do you have a set checklist that you do? Do you pass them to someone else for a high-level review? Is it someone else internally in your company? What procedures do you have in place, and what would you recommend for other people?
Well, for me as a sole practitioner, it depends on the project. If it's something simple, for example, a house beam or something like that, I just do my own check. I have a series of checklists. It's probably about four sheets long, primarily formed by all the mistakes I've made or have come across over the last 40 years. Sometimes that's very difficult if you've got a deadline to meet. I always try at least to think on the job overnight, and also try and just sit there, away from the calculations, and think, how's the structure going to behave? And I'm a great supporter of just stick diagrams on a bit of paper, simplified things, and then that way you can tell if you're order of magnitude out. for me, my quality assurance is not about checking decimal places or the last detailed calculation, but is making sure the overall structure is going to behave according to the loads as you expect and designed, and to make sure that the connections and the loads can get back to the ground.
Thank you. For those members in here who don't have one already, we actually have on the Engineering New Zealand website in the resources section a one-page checklist that you can use, that you're welcome to take and use it as it is or to adapt. I'll put my email address into the comment sections, and if you can't find it on the website, please email me and I'll send it to you directly. And okay, well, let's get on to the questions from the people. The first one here isn't actually a question; it's a comment, but I think it's very good. So, being the only qualified engineer working for the MWD at the time, and having carried out previous conservation work for DOC's predecessors, I agree with the statement that DOC failed to put in any engineering input. In fact, the field staff appeared to try and avoid engineering input, as it was seen to increase costs above what they thought was necessary. That was supposed to be working for the MWD on the West Coast. I'm sure that was true at the time, and thank you very much for the insight. And I certainly hope that behaviour has changed now. The next one is a question, and wasn't the terrible combination of deficiencies in this case fundamentally caused by the loss of corporate knowledge and good practice in the administrative restructure and transfer from one government department to another?
Yes, that came out in the Commission of Inquiry. And I think the lesson for us all there is still relevant. Is with today's corporate world and takeovers, mergers, you need to take some of the large consultancy practices in New Zealand, have gone from, for example, to use the Ministry of Works through the process of OPIS and then WSP. There are potential areas where some of this institutional knowledge and safeguards can be lost as an inadvertent sort of a thing. So I think we've all got to be very mindful of that, and also think about the culture we're working in, and it's changed, and unfortunately engineering and safety is not always the highest priority.
And I think the next one is to do with the age of the platform, how long it had lasted before it failed. What they're saying is, was there any evidence when this platform was constructed and when it failed? Is it state or privately owned?
Well, I think it was only a matter of a few months before the collapse, and of course it was part of the conservation estate, I understand.
Now, in the terms of issues Gordon raised, like engineering oversight, design, supervision, peer reviews, inspections, risk assessment, etc., do you think that DOC now follows those engineering processes on their structures, and is there still room for improvement?
I'm not personally familiar with the exact details, but I know there was a huge shake-up, and I spoke to several engineers that were doing this sort of work, and I understood it to be a very robust and thorough system, and that was several years ago, but I don't have any recent knowledge of the current state of play with DOC.
We've already answered question 5. And were there any penalties applied, and if so, to whom?
My understanding is there was no blame apportioned to any individual.
And have you observed over your career that New Zealand health and safety culture in general has changed and is changing?
Well, it's definitely changing for the better. My biggest concern, though, is that we're getting too tied down with paperwork and systems, and we run the risk of actually failing to identify the real problems and the potential hazards. That there's a huge bureaucracy around it all, and people are trying to save face or potential liability, and I just have the concern that maybe the pendulum's swinging a bit too far, and we run the risk of losing the objective, which is to make places safer.
And that's the last question. Thank you very much, Gordon. I forgot to say at the beginning of the webinar that that Gordon is representing the engineering general practitioners on this occasion. He's one of the committee members there and one of the founders. And please, if you are a member of a smaller practitioner, then we certainly encourage you to join it. It gives you a peer group that you can easily access and ask the questions of, and they do support a no blame culture there. The next webinar that we're going to be having is on from the transportation group, and Glenn Curry, who was formerly a lecturer at University of Canterbury and now one of the directors at the Austrata, will be presenting the webinar there. So once again, thank you, Gordon, for your time. Certainly appreciate it, and we'll be having all of the information up on the website inside the next couple of weeks.
Thank you.
Thank you.